All right, so this video is, I believe, 4.2a. It's the slope of a line. That's what we're kind of dealing with today. So 4.2a, the slope of a line. And we're going to talk about slope as a rate of change. So your note paper should say 4.2a on it, and that says slope of a line. Now, we'll start off with this this picture right here. I think it's pretty helpful. So we're at number 1 on this thing. And if we look here, we've got a couple of different things going on. We got a diagram that's showing the rate of change. So we want to see how these guys' height is changing, basically. So the diagram shows the side view of a ski lift. What is the vertical change from A to B? So what we should do is we should kind of focus on A and also B and find the change in height, like how high did they go. So A is here, right? And B is there. So, I mean, if A is at a height of 40, right? A is clearly at a height of 40. And B is over here. It's at a height of 50. It's on this grid line, right? There's B. What was the change in height? Well, the change in height from A to B, this, was 10 feet. So that's the first answer. Now they want to know the change in height from B to C. So the change in height from B to C, we'll use blue for C, and we'll still use green for B, obviously. Well, C is way up here, and C is at a height of 90. So if it went from a height of 50 to a height of 90, I believe that the change in height was 40 feet. It went up 40 feet. And then we want to know the change in height from C to D. We're running low on colors, so we'll use purple for that, and C will be blue again. So let's look at where D is. It's over here. And what height is that at?
Afternoon HS here. Afternoon announcements.
100, right?
Oranges and grapefruits for sale. Stop at.
So, like I was saying before I was interrupted by that young man on the intercom, we are looking for the change from C to D, and that's a height of 90 to a height of 100. So the change there from C to D is 10 feet. Now, you don't have to write this in the gray box. You can write this on the side. You know, it might be smart to kind of go over here and say it's 10 feet, the first question, and then it's a change of 40 feet, and then it's a change of 10 feet again. Okay, does that make sense? So that's where we're at here. Now we want to talk about horizontal changes. So same deal. We're going to look at the horizontal changes here. So what's the horizontal change from A to B? So should we continue to color code? Let's do it. A is red, B is green, the green point, C is the blue point, and D is the purple point, I suppose, right? The purple point. So there's that. So let's kind of look at this. I'm going to use the mouse. It's a little bit small, but it should be able to be visible because I can't really point with my finger while I'm recording here. So let's try this. You see the eraser there. From A to B, what's the horizontal change? So from A, it's at 20, you see that? And it ends up that B is at 50. So from 20 to 50, that's a horizontal change of 30. 20 to 50 is a horizontal change of 30. From B to C, it's at 50 here, between 40 and 60 is at 50, and then it's at 80. So that's a change of 30 as well. So we have two horizontal changes of 30 feet on this thing. So we have a change of 30 feet. That's the first question. Then we have a change of 30 feet. That's the second question. And then here from C to D, that horizontal change is from 80 to 110. That's also a change of 30 feet. So the answer to all of these is a horizontal change of 30 each time. That's basically what we're looking at. So as we carry on, we got to find the ratio of the vertical change to the horizontal change for each section of this ski lift. So the ratio of the vertical change to the horizontal change. So I don't really want to erase this. I want to kind of keep this information here because what I want to do is I had 3 answers each time, right? I had 3 different answers. And what I want to do is I want to take, and I'm going to have to use the same colors here. Maybe I can try orange or something. I want to take the vertical change and divide it by the horizontal change. So I want to take this change, the first one, from A to B, and divide it by the horizontal change from A to B. So that's going to be 10 feet divided by 30 feet. And I guess in that case, it's just 1/3. That's our first answer on number 3. So let's just kind of keep going through that process. Can you find the next two answers? So we want to take this and divide it by this and get an answer. Then we want to take this and divide it by this, okay? I'm using the same colors, but it's not really as much related. So take the green and divide 40 by 30. Take the blue and divide 10 by 30. And get your two other rates of change, I guess, your changes in y over change in x. And then I want you to answer question 4. So your now you tries right here, okay? And NYT stands for now you try. These are your now you tries. So I'm going to draw all over this because I can. And I'm going to say that these are now you try. So why don't you pause the video, think about what section's the steepest, what section's not steep, how did the ratio look in that, and give that a shot. So pause the video, and I'll see you in just a second. So I've moved on, and I'm now going to talk about the rate of change here. So I want to talk about the rate of change of this baby. This is a strange question. Probably wouldn't have seen this in Algebra book a few years ago, but nowadays this is kind of an important question. So I guess what we should kind of think about is the time, right? I mean, if we look at birth, and we look at time as the independent variable, right? We say time is x. So let's let x equal time. Okay? And if we were going to say x1, like the time where we start, is 0. Why is that? Because we're at birth. We're at birth. So that's what we kind of look at here. Okay, so what we want to kind of think about, and I was kind of talking about this being the independent variable, x1 is 0, so at birth is 0 times 0. You could call x time, or you could just call it t if you wanted, an L. I mean, you could say that x is equal to t, and that's time, and y is equal to L, and that's length. And you could just write the equation like that if you want. But if x is t, then you got to make sure that it's change in time underneath change in length, right? So what was the change in length of this baby? And I kind of was, I guess I'm a little scatterbrained here because I started showing you one way and now I'm kind of thinking about this. I kind of like this. So instead of change in x over change in y, I'm saying x is time and I'm saying y is length. So now I'm doing change in length over change in time. Well, what was the change in length? This is going to be way better than doing a slope formula on this. The change in length was clearly 9 inches positive. It got longer, like the baby got taller, if we like to say, or I like to call it taller. It seems weird to say a baby got longer. So the baby got taller. That's how I'm going to talk about it. And it took 10 months. And we should talk about units here. We have 9/10, and it's inches and months. So isn't it 9/10 of an inch per month? That's the rate of change here. Look at this problem. Rewatch it if you need to. It's an important problem, okay? I want you to pause the video right now and try number 3. It's a good question, and it's pretty cool. So I'll read it to you real quick. You're traveling from home to Washington, D.C. to visit Mr. Pasceri University. It's 800 miles away. You plan to leave at 8 a.m. and will arrive at 6 p.m. I want you to kind of keep in mind that if x is time and y is distance, it might be smart. It might be smart to, instead of trying to really go crazy with this, why don't you just try to do change in distance over change in time? If you can do that, you're good. I mean, because that's the same as change in y over change in x according to this, according to what I'm kind of giving you here. So pause the video and give that a chance. If you can figure out the change in distance and the change in time, you'll be okay. Watch out for that 8 a.m. and 6 p.m., but if you use common sense, you can figure out how long that was. So pause the video and give that problem a try. So this question is a pretty good question. You're draining your bathtub. After 2 minutes, there are 30 gallons. After 7 minutes, the tub is empty. This is another good now you try. So I know you just paused the video and tried a problem. I'd like you to also try this problem, okay? So give that a shot. You're trying to find the rate of change of the volume per minute. So, you know, change in y over change in x. Change in volume over change in time. So that's what's going on there. So pause the video, give that a shot. I want to keep moving, so I keep this video as short as possible. That's an important one, so try number 4. Okay, now I'm going to do one for you. Just kind of thinking about number 4. Number 5 is kind of similar. It's just that it helps a little bit because it's talking about rise and run, right? So we know that slope can be thought of a lot of different ways. Slope is really rate of change. That's important, which also means that it's change in y over change in x if you're on your regular old xy graph. You know this graph right here? I kind of made a really ugly looking one, but you get the general idea. And that's the same as like change in distance over change in time. I'm putting equal signs here to show that these are all the same thing. And it's also equal to saying rise over run if you're looking at this, this again, if you're looking at this xy graph, right? There's so many ways we can look at this. And sometimes people even call this the average rate of change. Average rate of change. Sometimes they call it that because, and that's not a vocabulary we'll use, but it wouldn't be a bad thing for you to understand because it's kind of like if you look at how you've changed in position and changed in time, that's your average speed, right? That's your average speed. If you go to Florida, which is 1,000 miles away maybe, and it takes you 10 hours, then you went 100 miles an hour. You shouldn't be going that fast, but that would be your average speed. Now, you'd be going faster sometimes, you'd be going slower sometimes, but that's your average rate of change, your average speed. Okay, and the last problem here. It's one of these link sheets. So I might do a little bit of it for you, get you a general idea of what's going on. This is number 6. And what's happening is Jake runs a computer shop out of his home. He charges a flat fee for taking on the repair job in addition to an hourly rate. So it looks like he's earned 32 by the end of the 3rd hour and 56 at the end of the 5th hour. If we can put that into some sort of XY thing, we'll be in pretty good shape. So I think that the independent variable, what you have control over, if you think about it, is how many hours you work. 3 hours or 5 hours, right? You can control that. So I'm going to actually just use this, the 3rd hour. So I'm going to say after 3 hours, and maybe we should say it's hours and money, right? That's kind of the thing. This is our x and y. It doesn't have to be x and y. It can be hours and money. It doesn't have to be x and y. It can be time and distance. It can be time and length of the baby, right? So after the 3rd hour, he's got $32. Okay, that's a thing that happened to him. So after the 3rd hour, so I guess here, he has, I don't know, 5, 10, 15, 20, 25, 30, $32. I guess I'll put it here. So there's that point. Now I want to talk about what's happening here. He has, after the 5th hour, so 5 hours have passed, and he has $56. So 5, 56. And I'll go to 5, which is here, and 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 56. That would be what's going on there. So you wanted to just construct the data table, the graph, answer some questions. He charges a flat fee. So we're going to need to try to figure out what's going on there. I know that if I have 2 points anywhere, you don't have to have the y-intercept. Any 2 points will give you, right, can give you the graph of a line. So I'm just going to go ahead and take these 2 points and draw a line through them. Try to figure out what's going on here. Oh, interesting. Okay, let me just check my data here. Make sure I haven't messed anything up. 5, 10, 15, 20, 25, 30, 32. Okay, that's after 3 hours. After 5 hours, 5, 10, 15, 20, 25, 30, 35, 40, 45, 55, 56. So we should be right and around here. So I think this is what our line should kind of look like, something like this, right? Interesting. And this much here. Okay, well, let's try to keep on going from this, okay? So what is his hourly rate? Well, how many hours happened here? How many hours, like, what was this? This is 2 hours, right, that are passing from here to here. So in 2 hours, per 2 hours, what happened here? How much money did he make? He made $24 in 2 hours. So I believe that Jake charges $12 an hour. I don't like this data table, so I'm just going to get rid of that for just a second. The scale's a little bit weird on it too. That's one thing that might be tricky. So this is 10, this is 20, 30, 40, this is 50, and this is just regular 5. This is 8. Okay, so you get the general idea. So we know that he's making, I think he's making $12 per hour. It seems that's clear. And I want to make a bunch, I want you to fill in this data table with a bunch of points, okay? Give me a bunch of things. This is the money that's coming in. This is the hours that he's worked. And then maybe you can write an equation here. This is my hope. That's stretching it. But I want you to answer the questions. So also right here, this is your now you try. And this is your now you try. So I want you to pause the video and try both of these things. And that's where we're going to wrap it up. I just want you to do your best with this sheet and see where it gets you. And we will pick it up tomorrow. Thanks for watching. Thanks for listening. I'll see you in the next video. Peace.